Let's talk about replication in a Cassandra ring. A very important topic when it comes to operations, but also when you do data modeling. It's really the understanding of where your data is and how that data model applies to where your data is. But this is really fundamental. How does a Cassandra ring replicate data? In my opinion, this is the secret sauce of how Cassandra has owned the world when it comes to replicated data. No one else does this, and it's really special. So what is it? Replication is very simple, and I think that's the best part of how replication in Cassandra works. It fits in your brain. So in this case, where we have multiple nodes in a ring, each node is responsible for a certain range of that data. As you know with a partitioner, the partitioner is the one who says, oh, this is the range of data each node should own. But in this case where we have just one node owning the data, you could have potential problems. Say if you lost a node, say the one with 13 or 25 on it, that means in this case you would lose a portion of your data. That does not work because in the world we live in today, guess what? Nodes are going to fail all the time. Wait, when have you ever had a server that's never failed? Yeah, never. Okay, so this is a really good idea. Let's replicate some data. So in this example cluster with just a replication factor of 1, meaning only one copy of your data per node, how does the data get moved around in the node? So this is how a coordinator works. When data is written into the cluster, this particular piece of data has a partition key that's been hashed to the number 59 as an example. If it's written to this node that has the range up to 13, well, hold on. That's not the correct node for the data. The coordinator on that node is smart enough to know the placement of data around the ring. This is where the snitch comes in. That coordinator then asynchronously copies it to the correct place. In this case, in the range that covers the 59. And this is how you can write to any node in the cluster. Super important, because if you have node failures, you want to be able to work around those failures. It's just like how the internet works. Work around the problems, just expect failure. Now, if we were to update our replication factor to say 2, this is where things start getting really interesting. Each node now is storing not only its own data, but its neighbor's data. This is a very friendly neighborhood. Everybody loves to help out everyone else. This is a beauty and the power of a Cassandra cluster. So in this case, you can see that each neighbor stores its neighbor's data. So we have 2 copies of the data in the cluster. So each node stores 2 copies. Awesome. So if we have a failure, now we've avoided the possibility that we lose all our data in that particular node range. But whenever we write data into the cluster, again, the coordinator is smart enough to know the layout of the cluster. That data will be asynchronously copied to the correct places where the data lives. So for instance, in the primary range and in the replica as well. That keeps the data consistent throughout the ring. When anyone asks you how much data should we replicate and what's the replication factor, usually the answer should be 3. And not 4, and not 2, unless directly proceeding to 3. You see what I did there, right? Well, 3 is a good number because it gives you a balance of how much data you're copying, meaning the cost, and also just taking advantage of the probability of failure inside of a Cassandra ring. In this case, this is hardware and hardware fails. The chances of 3 servers failing at the same time is really, really low. 2 is low, but not impossible, and 1 will happen. So replication factor 3, really good place to be. And again, when we add that data, it's the neighbor's data. So the neighbor, neighbor, neighbor. We start seeing the data spread throughout the ring in a consistent way. That data is also findable by the coordinator. So when you're writing data into the ring, you know that it's going to go to the right place because that topology is being shared throughout the ring. So now we know that whenever we write data into a replicated Cassandra ring, we're getting good consistency. And we know that we can withstand a lot of failure. So what happens during a failure? Let's say you have, a shark attack on one of your nodes. Never know, it can happen. More likely, it's probably going to be a power failure or a disk or something like that. But shark attacks are possible. But if that node goes out for any reason, how are you going to handle that? So replication saves the day. Because when you are spreading your data around in a really consistent way, that's going to make failures a lot less of an impact. In this case, we have 2 nodes that have gone down, and they store a certain range of data. But since we've done a replication factor of 3 and we've spread data all around our ring in a very neat and orderly fashion, when we write data into the cluster, look at that. It has a home for that. It will be able to write data despite the fact we had 2 nodes fail. Now, the first time that ever happens to you in production, it's pretty magical. It will change your life because if you haven't been using a database that replicates like this, you are expecting everything to fail. And when it doesn't, you look awesome. You feel awesome. And this is just the basics of how it works. And this is one of the things that makes Apache Cassandra an amazing database. But what about multi-data center? This is, I think, the most important part of our replication story. Multi-data center is hard. When you try to add multi-data center to any other database, it turns into a real mess because you can't get the architecture just right because it wasn't designed to do that. Here's the beauty of how Apache Cassandra does replication. When you have 2 separate data centers, either physical or logical, that means that it splits up those ranges in these configurations that lets that data spread out neatly across the different data centers. So when you're writing data into your cluster, you know that it is being replicated properly. Now it uses the snitch to make sure that the data is indeed replicated because it is topology aware. However, how it replicates is really interesting. Whenever you set up the key space with replication, again, key space stores replication information. In this case, we have 2 data centers, west and east, and we're specifying a certain replication factor independently for those 2 data centers. That's pretty cool because now you can be very controlled in how you replicate your data. For instance, you could change one of these to 0 and not replicate any data to it at all. That is a really interesting way to control things like how your data is replicated in, say, in a data protection environment. Say if you can't replicate data into another country, you can control it by changing how you do your replication in your key space. In this example, we have a very simple case where we have 2 data centers and we want to replicate across both of them. Now, how does that work from an application standpoint? When we write data into one data center, that coordinator's job is to write data inside the data center, but it also, knowing that there is a topology that has another data center, it says, hey, I'm going to asynchronously write this to one node in the other data center. When that node gets the data, it acts as a local coordinator, and that data is asynchronously copied, again, inside that data center. So you get a very consistent and very clean way of replicating data, and it does this so nicely. This has been done since day 1 of Cassandra. And it is really the most basic and important part of Cassandra is its replication story. So now we're going to do an exercise so you can see how replication works.